Welcome back to our 31-part series. This is part 2 of our little mini-series within this, the panel discussions about chemistry of indoor environments, this 10-year-long program that learned so much about this stuff. By the way, I just want to mention, if you haven't been keeping up through these or haven't been watching all of them because you saw the thumbnail and you see that I'm keep talking about like wildfire smoke, I promise you, none of these researchers is repeating what another one said. They are all talking about very interesting, very specific things. So I highly recommend that you watch the previous dozen or so videos and that you stay tuned to the rest of this because we're all learning an awful lot about this. The last session was all about the health impacts and exposure risks of indoor chemistry. Right now, we're going to talk about the technology end of things, the products that do and do not work. This time, again, I'm going to set it out, and you will just hear from the researchers as they have this kind of wide-ranging conversation on the topic. I will not be pausing and interjecting anything. Here we go.
Hello, everyone. I'm Vito Ilacqua. I'm at the Environmental Protection Agency in the Office of Air, and we in the Indoor Environment Division. And we are the ones that develop guidelines for the public. And as everyone probably has realized during the pandemic, we saw an explosion of interest in all things indoor air, which is great. And at the same time, we also saw an explosion of creativity in how people deal with indoor air quality problems, and in particular in using air cleaners. And I want to call it traditional approach, but one of the most well understood approaches to air cleaning has been using mechanical filters. You remove particles and you remove the viruses on them. And now I can't help but also think of viruses as stick figures on top of the larger particles too. And so you remove the particles, you remove the viruses as what you've seen, but people have also thought about other ways. Maybe you can inactivate the viruses on the particles. Maybe you can make the particles more likely to deposit where you want, hopefully, or in general. And a variety of other techniques. And so this is really one of the questions that we get the most from people and from schools and other organizations like that. And so today we have a great panel, a big panel. So we may not have everyone be able to respond to every question, but I'm glad to have here Tunga Zalthammer from WKI, and then my colleague, Katherine Ratliff also from EPA in the Office of Research, Dustin Poppendieck at NIST, Delphine Farmer at the Colorado State University, and then Jose Jiminez at the University of Colorado, Boulder. So with that, I'm going to sit here too, and we'll start with some general questions and then maybe open up to questions from the public. And I think one of the ways to start here is to think about, we use air cleaners to create good indoor air quality, but what is good indoor air quality? I think someone had actually a slide looking at that. Can we start maybe, Tunga? What do you think? What can you say we can define good indoor air quality?
Yeah, I cannot really respond to this question. We have criteria in Germany for good indoor air quality. This involves many parameters: temperature, humidity, air exchange rate, and many pollutants. And we have, of course, the perceived air quality, which is also an important topic. We can have a low pollutant level, but people can perceive air quality as terrible. So there's no, and everybody perceives air quality different. So I cannot say I cannot define good indoor air quality precisely.
Other anyone else wants to take it.
Oh, okay. I'll go back to what Michael said this morning, and that there's Tunga basically defined an indoor chemist definition of what indoor air quality, good indoor air quality is, or lack of definition. But when we think about the built environment and all the people that use a built environment, people that design the built environment, we have to think about what other people think about in the built environment. And so, as Michael was saying this morning, the occupants just want it not to smell. You know, they want to make sure that they're not going to get sick and they're not going to smell. That's their concern. The public health experts want minimal disease transmission, and the building operators want it to cost the minimal amount. And so when we start thinking about air cleaners and how we go into the air cleaner discussion, we really need to think about all of these different silos and how they interact. And what has happened in this field is basically people coming from a public health perspective, let's end this transmission of diseases with UV or other technologies, have gone to the building operators and say, hey, I've got a really low cost solution for you. And this is why we get all these excitement on these new technologies, because one silo is talking to the other silo without any communication with the third or fourth silos. And I don't think the building occupants are even considered when we start having these discussions on what perceived good indoor air quality is.
Thank you. And so now we are talking about indoor air cleaners. Can maybe each one of you take a couple of minutes to tell us how you got involved essentially into research on indoor air cleaning, and so how you end up here on the podium today? And let's start with Jose.
So I got involved accidentally on disease transmission during the pandemic. And then, one day I was talking to people on Twitter, and then they said, we have this.
Is it on?
Oh. Okay. So I was talking to people on Twitter, and they said, we have these UV lights. And I asked, what about the chemistry? And they said, what chemistry? So then, I'm pretty sure there is some chemistry. So we started studying it, thinking it would be small. And that has evolved to the point I'm the least popular person. I'm pretty sure they have voodoo toys with needles in that community. But just to touch on a few points, there has been during the pandemic an obsession with disinfection for obvious reasons, which is important. But actually, I was like we all do in this field, you work very hard and then you discover that Charlie Weschler wrote a paper 20 years ago where he already... So and like a lot of the killing that outdoor air pollution do, PM and ozone, happens because we breathe it indoors. If you do the calculations, that is pretty clear. So there's actually a huge opportunity to reduce the burden of disease that's caused by air pollution if we were to clean the air of particles and ozone. And this is completely ignored. There is all this fear of the virus and this ignorance of the pollution that we are exposed to. It's kind of like radioactivity and chemicals. People are extremely afraid of radioactivity, but then we put these flame retardants everywhere. So I think that's one issue. And then, anyway, I'll leave it there for now.
All right. So I think my interest in air cleaners started during the pandemic, and really early on, there were all sorts of people who were trying to use lots of bleach. There were reports of people using bleach on streets in Southeast Asia, and then fogging offices and dental offices with hypochlorous acid. And we've done these studies in home chem and following John Abbott's group, and really realizing how much reactive chemistry there was, coupled to the fact that we as a community were beginning to realize how much reactive organic carbon there was indoors. And once you start thinking about those two components, adding reactive chemistry that makes chlorinated compounds coupled to the incredibly reactive air we have indoors, that that started to really scare me as a chemist. And at the same time as the beginning of the pandemic, I was teaching environmental chemistry, and a focus of that class is the idea of the precautionary principle and talking about these classic outdoor environmental disasters. And a lot of them come out of the fact that people weren't thinking about the unintended consequences of any chemical addition to an environmental system. So putting those two together, I started to get really concerned about what was happening if we were putting reactive chemicals into the indoor system without really thinking about the consequences. So that started a set of thinking about bleach. It's then moved to other oxidants. And then I started to learn about these very creative approaches of ionizing indoor air and oxygen. And I was thinking, well, ionization, that does chemistry. And if you go into the old literature from the old atmospheric chemistry literature from the 1970s, there, then you go into modern literature where we think about chemical ionization, there's again the potential for incredible unintended consequences. That then, of course, resulted in the unintended consequence of a few subpoenas and a few other issues, but, unintended consequences in all sorts of perspectives. So then finally, with CASA, you got a hint from Jinminez's posters and his talk today about sort of how we're beginning to think about more broadly about air cleaning, about when things are effective for different types of particles, about when they're effective for different types of gases. But also, I think there's a really large effort required on the part, and it's not just one group, it has to be a community effort, thinking about how do we study these unintended consequences and make sure we make very wise decisions about cleaning air.
So I'm not a chemist. I'm an environmental engineer with 7 years of very detailed, highly education of how pHs move in soil. So I'm a perfect person to talk about how gases and particles are removed from air. And it's 20 years since that time, though I have done a bunch of indoor air quality stuff, and I didn't really think the impact was as much as I'd hoped. But then this opportunity called the pandemic came around, and I had the same thoughts and interacted with some of the same people on Twitter. And, I thought, we don't have an adequate standard. What we need for air cleaners is we need a technology agnostic test that basically tells us, it's basically, we need a do no harm test. I don't really care if your product works, but I want to make sure it doesn't degrade the indoor air. And looking at the landscape of testing that we have tests that look at particles, large particles, 300 nanometers and larger. There were some chemistry tests out there, but they don't necessarily mimic real world environments. And so I tried to put together a working group that has more knowledge than I do to try and come up with a test that we can actually fairly evaluate technologies across the board that are not biased towards any of them. Luckily we were able to hire Michael to do all the work and come up with a test method. So with the data that Riley presented in our poster last night was basically looking at how we developed the method. We aren't so concerned about any of the individual technologies and what any of the individual technologies produce, but that we can come up with a method that actually gives us representative tools that we can actually, or data that we can actually evaluate across technologies and make sure that, if they claim they're removing formaldehyde, are they really removing formaldehyde? And have an indicator of species that we can look at to say, is chemistry happening? So not just going beyond the carb limits of capturing ozone, but also formaldehyde and nanoparticle formation. And so that's where I'm coming from, is trying to establish some kind of level playing field that we can evaluate various technologies and various products to make sure that they're actually performing to the level they are. And those of you who are older might remember something called consumer reports. And, that's what we're trying to do, get a consumer report test that we can give to people, schools, individuals, that they can actually look and see that you get to the bottom line, do no harm.
All right. So I'm the least chemist on this stage, which is the big disclaimer. So I'm the person that in Michael's slide earlier, you put up the what do you think about indoor air quality, or what's good at indoor air quality? My first instinct is to think, pathogen-free air, but I've come strides from there and think about it more holistically now. So appreciate the opportunity to be here. So I'm from the Office of Research and Development at EPA, like Vito said, and in addition to doing research, we provide a lot of technical support to various stakeholders, people in large transit agencies and schools, all different types of settings. And over the progression of 2020, we started getting all kinds of questions about, what kind of air cleaning or treatment technologies can we be using in our spaces so that as people come back and repopulate these indoor environments, we can do that safely. And as we started to dig into the data and the products that were out there, we realized it was an impossible question to answer. So where Dustin said you don't care if the things work the way that people claim they do, I do care about if they work the way that they claim to do against the infectious aerosols. So that was my primary, or has been my primary focus over the last few years, is leading EPA's research to evaluate the effectiveness or efficacy of all the different kinds of air cleaning and treatment technologies against airborne pathogens. So we were able to secure some funding to get really unique facilities adapted within our Research Triangle Park lab. We have a 85 cubic meter bioaerosol chamber that we've been using to test all different types of air cleaning and treatment technologies. So as I'm sure many of you are well aware, the lack of standards for these technologies mean that they're often tested in very different ways. They're often tested in a glove box or at really small scales. And so there are claims that are out there about 99.9%, 99 point, however many nines you want to put on there, effectiveness in reducing the infectious aerosol load, and then trying to relay to consumers that translates to the occupied space that it's being used in. Clearly there are problems with that. So we've been using the laboratory facilities that we have to conduct testing in a systematic way, using the same type of methodology as much as possible across the different technology types, whether it's installed inductor in room, an ionizer, a HEPA filter, 222 or 254 nanometer UV, trying to use standardized methods so that we can actually compare the effectiveness across the different types of technologies in a way that helps us inform end users and customers for what types of these air cleaning technologies are appropriate to use in different settings. So in reporting data or talking about effectiveness against bioaerosols, realized pretty early on that, if we're just talking about that bioefficacy data, we're not talking about the whole picture. So I've been fortunate over the past few years to talk and sort of coordinate and collaborate with a number of the folks in this room to try to make sure that, we're putting forward that holistic picture of reporting the chemistry information and the bioefficacy data so that we have that full view and are able to really weigh the pros and cons, the costs and benefits of deploying these different technologies so that hopefully folks can use them effectively and responsibly.
Okay, before I start talking about air cleaners, thanks for the question. A good indoor air quality is now in my brain, and I'm thinking about it all the time. What it is, I have really no solution. I was supposed to say it is to adopt a WHO definition that is if people feel healthy in an indoor environment, but it's also wrong because maybe 10 years later you die from radon exposure. Okay. So I will think about this the next couple of days, I think. So air cleaners. I'm a chemist. I'm with a strong focus on analytical and physical chemistry, and unfortunately, I deal with air cleaners for more than 20 years. I work for Fraunhofer, but I'm also linked to the Technical University of Braunschweig. And if you know Fraunhofer, we work a lot for industry. And we tested over the years, I think, so many air cleaners, dozens or even hundreds of these. And they have all different technologies, and I have very different experience with industry. I have very good colleagues in industry, people who are really interested in improving their technologies. But on the other hand, there are also, especially during the pandemic, there are so many black sheep who wanted to conquer the market in a very aggressive way. And the people were coming and say, hey, we give you 10,000 euros and you give us a certificate. I said, of course, I cannot do this. I work for Fraunhofer. I want 100,000. No, I'm joking. I think that's recorded. I cannot say that. To make that short, we as I say, I experienced so many different air cleaners, and what I learned is not the technology of the air cleaner is the decisive point. It's the design of the air cleaner, independent of the method. If it's a filter or if it's PCO or whatever. For me, air cleaners, and I usually talk about mobile air cleaners here. This was the story during pandemic in Germany, is also a very political issue. Unfortunately, during pandemic, I was the chairman of the Indoor Hygiene Commission in Germany, and I had to write most of the statements for our environment agency on air cleaners, on an air quality. And then these statements were used in our discussion with the government, with the public, and with the manufacturers of the air cleaner. And believe me, and many of you might also have experienced that this was very, very stressful discussion, and there was a strong pressure on the schools, for example. The main topic in Germany was schools to use air cleaners, and I'm not convinced. We had many discussions. I'm not convinced that it helped. So in my home city, I was very happy that I convinced people not to buy air cleaners. We found a very effective and very simple solution. We just used fans. The story of the air cleaners, we can discuss this later, has one big disadvantage, and nobody would like to know this. A new air cleaner that is probably working is probably a good thing, but one day it gets polluted, and then it has to be cleaned. The air cleaner has to be cleaned. The pollutants have to be removed. Has to be maintenance and so on. And the people in schools, in German schools, will never in their life do that. So an air cleaner, one time switched on, will be switched on for the next 5 years. And this is the worst thing you can do in an indoor environment. So finally, fortunately, the pandemic ended before the air cleaners conquered us, but I'm afraid that the manufacturers already made so much money with their different technologies. And I'm a little bit tired, to be honest, of the air cleaner story. So many thanks, Glenn, for inviting me to this panel here.
All right. Thank you. And so why don't we dig a little deeper into some of these technologies and the air chemistry? What do we know, what we would like to know for some of this technology? I'm picking some from in a random order, but these are all questions that we get from the public. And I think perhaps, Jose, you want to pick UV light, since you started with that, your introduction. So what do we already know in terms of what kind of chemistry do we observe, and what would we like to know still?
I think it has become clear in the last year, although it was a surprise to the medical community that was pushing UV, that some wavelengths of UV, especially the more exciting ones that can shine on people directly, create ozone, and create enough ozone to create trouble. I mean, we already saw that 10 ppb of ozone is a big deal indoors. And that ozone can then go on to make particles. It can be photolyzed to make OH. So I think that's already pretty well established. Some of the quantification, for example, of the particles is still up in the air. And then, for example, is there more chemistry that happens with the UV interacting with the volatile organic compounds in the air that I think we all suspect, but there is almost no data? Because basically that chemistry has been studied for the stratosphere, where they don't happen to have the chemicals we have indoors, right? So those communities have been separated. And also surfaces, like there is some observations already when you shine this UV light on the surface, suddenly all these VOCs appear, which won't surprise Vicky or the people who spoke earlier. But I think that's also an open question.
You. Let's think now about how about photocatalytic devices? Who wants to take that?
I can do that. So there's a whole array of devices that cover a sort of diversity of versions, but there's, you can shine ultraviolet light on a very special catalytic surface. And the idea behind these is might generate OH radicals, other oxidants, and those might eat away at volatile organic compounds. And so those devices, many of them, and I think Dustin alluded to this really nicely, have been tested in very controlled lab settings. What happens in the real world is a very open question, because we know, again, there's this huge amount of reactive material that you then put in, and now you're going to interact it with oxidants and perhaps also light of varying forms. And so we're going to produce a diversity of products. Now, these devices generally have the intention of making CO2 and carbon monoxide, something relatively benign. But the oxidation is very unlikely to get all the way. So I think the big questions that we have about those sorts of devices are, how well do they work in a real world environment, not just in a shoebox? How effective are they in terms of any of the indoor air quality metrics we're all very uncomfortable about putting a name and a number to, but how effective are they cleaning in a real world setting? And then what are the chemical products that they release into an environment? Do they release oxidized VOCs? Very likely. Do they release them at levels that we should be concerned about in a real world environment? I have no idea. And so I think those are questions that we really need to answer as a community.
Yeah, I can make it short. Old techniques, I know, PCO or electric discharge or whatever, produce byproducts. We cannot seriously avoid that. It is okay, as I said in the beginning, if the air cleaner is, let's say, correctly designed. I know many devices who use PCO, and this is okay, but there are sometimes backup filters of charcoal or HEPA filters, and these devices they work. They work, but if you have just the PCO and the lamp inside and no filter, then you have more byproducts, and the formation of byproducts is higher than the efficiency for the removal of pollutants. This is very simple.
One other thing I'd like to add on the PCO factor, but it applies to all air cleaners, is long-term performance. And so, Katherine loaned me a PCO device, and we did it with our standard method, and we have a nice clean chamber, and we turned it on, and formaldehyde just started shooting out of the thing. I don't know what you did to it, but there was no real substantial VOCs in the chamber, and it just started producing steady state concentrations of formaldehyde. And so, you can design these to be perfect in the initial case, but what's the long-term impacts of when you start exposing them to these real mixtures of VOCs and these real-world conditions? Does that performance stay stable? I think that's another unknown for PCOs, but it's also applicable to a lot of different systems.
Add something quick, Dustin. You can keep that one. I don't think I want it back. But also a little anecdote on a different PCO device. So a manufacturer was trying to work with really large transit agencies in different locations throughout the country to install PCO devices in buses and subway cars. And they had done in situ testing for ozone and seen, in these fairly well ventilated vehicles, that they didn't have measurable elevated ozone concentrations when you're opening and closing doors. And it's a relatively large space compared to how these things are often tested in the lab. And so when we took the device and installed it again in a pretty sizable, 85 cubic meters is pretty big for a biological efficacy test, saw high concentration, over 100 ppb elevated ozone concentrations. And the manufacturer was shocked, but I think it speaks to the fact that we need to be testing for the chemical aspects and the biological efficacy under conditions that are similar to be able to get that holistic picture. Because otherwise, you know, again, we don't, if we're testing these things in different ways, we're just not really pushing things forward.
And I'd like to add one more note, because you pointed out something that links to what we heard about this morning in terms of just a small amount of ozone addition. Even if you only see, say, 1 part per billion or 0.1 part per billion, those are hard to measure indoors. But even if you only saw that, that's not necessarily the amount that came out. And as we saw on that beautiful figure this morning from Jim, that demonstrated very clearly, it's not just about the amount of ozone coming out, it's about the amount of ozone that reacted, that, again, we're not necessarily measuring. So when you start seeing these levels in situ in the real world, that's very alarming.
Let's do another technology that it's perhaps one of the most common questions that we get: ionizers. Who wants to take that?
I can start from a biological efficacy standpoint, not that that's why you all are here, but I will say that we've tested multiple ionizers from a biological efficacy standpoint. They have never performed to the degree that the manufacturer has claimed.
So the Colorado State Attorney General's office tells me that this is part of my job and therefore I'm legally protected. So ionizers have this problem that they generate just huge amounts of, well, either they don't work, which is, I think, probably quite common. If you don't see any ozone, any OVOCs, or any change in the real world environment, they're probably also not doing much for aerosol particles. There's been some really nice work led by Brent Stevens at the Illinois Institute of Technology that did some of the first studies trying to look at whether or not these even removed particles. Within the uncertainties, they don't really do much. Maybe they make some new particles from some other studies from Tim Bertram's group, but they just aren't doing very much, exactly as Katherine's saying. And so then you start wondering, okay, even if they are doing things in these testing environments where they show that in some sort of chamber you're removing biological material, in that case, then we have to be very concerned about the chemistry. And so, yes, the chemistry is unknown. There are now a few studies. I'll point to the Bertram group and the Stevens group in terms of studies that are showing whether or not these things are making particles or oxidized VOCs. But they're just not effective. So then one wonders is how far it's even worth going in terms of thinking about the science. And I think there's some interesting questions there. But yeah, they're going to make oxidized VOCs if they're going to work. And how much? That's open.
So that we're not just partial to mechanical filters. Can we say anything about mechanical filters from the standpoint of volatile organics released, or any information that we have on that side?
I think before we go to mechanical filters, I think we need to take a step back and realize, we talk about these individual technologies, but in reality, when you go to the market, most of these things are combined. So you have one technology usually with a mechanical filter, or one technology with a second technology. And when they add that second technology, they add another name. But it's really just summations of various technologies that have existed. When we start talking about VOC removal from mechanical filters, it really depends on the activated carbon. And, most consumer grade activated carbon filters that we've tested, and I've seen some other tests other than the wildfire smoke where you had really, really high concentrations. We haven't seen a lot of demonstrable removal performance of VOCs from those materials. If you think long term, we need to think about chemicals, the particles that are building up on those. They start collecting all the chemicals that you would see in dust are now on those filters, and then you bring ozone in, and so you have reactions on those filters. And so you have to start thinking about what's the chemistry on the actual mechanical filter long term, not just that initial state. But as far as a removal mechanism, in general, we don't see a lot of removal.
Yeah, I can. Dustin is right. Filters. It depends on the filter, of course. I'm not sure about how you call this. We in Europe we call it HEPA 13, 14, whatever, or F9 filters or so. This is very good for particles, and we work with some, let's say, very good people from industry who have really innovations combining, as you say, Dustin, combining filters with adsorbents. With new absorbents. A filter doesn't help against VOC, but a combination of an active charcoal or something different, and in combination with the filter, that is quite effective. But during the pandemic, a new idea came up, which is also interesting. These filters also help or also help to collect bioaerosols. And then, of course, the bioaerosols are on the filter. And then the question was how to remove the bioaerosols from the filter. Well, and the idea was to heat up the filter. And this is a good idea for the virus, of course, but then the VOCs are released from the filter, which this is the big disadvantage of the story. So yeah, this sounds funny, but at that time it wasn't so funny. But your question was on VOCs. I just wanted to add this story. If you have a good fiber filter in combination with a good adsorbent, that helps. But as I said at the beginning, this has to be changed from time to time because the pollutants are collected on the filter, and this is very expensive. This is cost effective. It's a little bit like the laser printer principle. The printer is cheap, but the cartridge is expensive, and this is exactly the same with the air cleaners.
I make a general point motivated by what a lot of my colleagues said. I mean, I think we have to realize that, especially during the pandemic, this was a field driven by money, and these companies got a lot of money, and that was driven by marketing. That was often, very misleading. Now, we are not a match for what happened in the real world. We tried, but I think the reaction we got, certainly in the US, as Delphine said, is don't get in the way. Here is a subpoena, and really being very aggressive. And I think Tonga mentioned similar things. And it's very difficult. I mean, we've learned that maybe we're a little more protected, but now and there was a lot of corruption. I mean, I think we can say it that way, as Tonga alluded. And I talked to many politicians during the pandemic, and they wanted to know what they could do. But then what we ended up realizing, they wouldn't do what we told them. They would do whatever will give them the largest commission, honestly. And they would often buy very crappy stuff that they could buy very cheap, sell very expensive. I mean, this happened all over the world. And I think, and touching on the ionizers, and some of these technologies are a scam. I mean, ionizers are a scam. I think it's basically, and other technologies anyway, let me leave it there for now.
I'm a federal employee, so I won't endorse what he said, but I'm not saying anything else. But I do want to say that this is a long-term thing. If you ever want a really fun story, ask Jess Siegel about his interactions with lawyers in the 2000s related to air cleaners. I know 4 of us here have all talked to lawyers related to air cleaners. So it's one area of indoor air that you don't really think about until you start doing it, that, it bumps up against lots of money. So
I'm going to ask one more question, and then we'll check if there are questions from the audience. And this, picking up on something you raised, Tonga, earlier on the issue of design. And Dustin, you also talked about the multi-stage devices. Is it possible? Is it really a matter of design? Is it possible to devise air cleaners that use these technologies? They do their thing inside the device, and then you somehow stop it at the end from being emitted in the air that people are breathing. Is that a good approach? Should we think about it that way? What can we really think about these multi-stage devices?
I'll happily start with this. I think, is it possible? Absolutely. Engineers are amazing people, and they can come up with lots of very good creative solutions. However, we know from decades of environmental chemistry, we know that if you come up with a solution to cleaning up something that's dirty, it's always going to be more expensive, more difficult, and have unintended consequences. Whereas if you just cleaned up the problem or didn't create the problem in the first place, you would have a much better solution. So I will very strongly argue that the best solution to clean air is to stop polluting it in the first place. Right. And so that's what we should be striving for. And I would argue if we took our money and our creativity and the incredible, the intelligence that is sitting in this room right now, if we all sort of were able to convince people that there are solutions to the sources, then that's the place you want to start. If you look at the hierarchy of controls, that's where you start. You stop the source of the problem as opposed to trying to put a Band-Aid on the solution at the end. So I would argue that's what we should be trying to push for. Is it realistic? Not in every circumstance, for sure. So in that case, some very careful design. Possible? Perhaps.
Yeah, I agree. And I would like to say, in my view, an air cleaner, especially a mobile air cleaner, can always be a short-time solution in case of an emergency. It's like the pandemic. If you have a virus and you would like to you have to remove the virus. If you find a device that is working, I said there are some of the air cleaners we tested worked, most didn't work, to be honest, but it is always a short-term solution. And this, I would like to link this to the surface session. We did a study, I think in 2019. We doped dust with SVOC and spread this into a test house we have at WKI, and then we switched on the air cleaner. And these, of course, the level of pollutants was reduced, but in a minute or in a second, we stopped the air cleaner. The pollutants came back because it is exactly what we had today. The reservoir on the surfaces, in the dust and everywhere, is so big that if you wish to reduce your pollutants with an air cleaner, this is only possible if the air cleaner is switched on. This doesn't help you on a long or on a medium term. And what we need is pollution control, and we cannot reduce air pollutants by mobile air cleaners for a certain time. I can really not recommend that.
I take a slight disagreement with that, but I think we need to define what we mean by air cleaning and what our goals are. And so if your goal is to remove chemicals, I completely agree with Tunga. If your goal is to remove particles, putting a portable air cleaner in your room that has a high cleaner delivery rate may be more effective than your intermittent air on your HVAC system. So I think there are roles for these, but we have to be very clear about what the purpose is. If we're using an air cleaner and a portable air cleaner to try and stop transmission of COVID, that's not a UV-based system. That's not appropriate use for that in many cases. So I think when we were saying whether or not air cleaners are useful, what we need to define what the problem is before we start answering the question.
Great, thank you. So I see at least one question from the audience. Please.
So the song. All right. So I would probably make more a comment questions, but maybe mixed. So I think about 10 years ago, Bonnie was there visiting Tsinghua University. Those are engineers. The building, whatever the department is, it's not health or chemistry department. It's engineering in Ping. Anyway, so that's the time probably ambient air pollution peaked in Beijing or Shanghai, 2013. And so I was trying to do some work, but comes to a very practical question from my mother, from my in-laws, from almost everybody that I know, saying, We know that PM 2.5 is hundreds, right? Very high. And now what can we do? Should we use air cleaners? Because the industry were there. Those 2 years or 3 years, the number of HEPA filters or whatever air purifiers, maybe someone not HEPA based, was record high, was total number, whatever. So, but the question what the public asking is whether this thing's going to work or not, right? So I think that's really driving a scientific kind of question. We need to really show that this thing improves health or not, right? Because the lab test is very clear. HEPA filter removes 99%, 99 above percent of PM. And in real homes, you will see also reduce 55 or 70%. But doesn't that really translate to health improvement? So we launched several studies. I would just say one experience I had is the study with actually I showed that was the old data set, was the 43 children with asthma living in Shanghai. And I tried to recruit those people, went to a clinician, two clinicians. I said, I want to test this, I want to answer this question, but would you be willing to help? The friends, whatever they do, but they told me they never thought this going to work. He said, clinically, we know the asthma, the children have the small airways, that's the hardest place. You give them the nebulize the drugs, the droplet don't go that deep to the lung. So if you really want to see the airway improvements in the lower airway, it's very hard. But we designed this study 2 weeks, use a HEPA filter, whatever. We show that the small airway air resistance got improved. The pheno improved 30%. She said she completely changed her mind. And she went to talk to every doctor, says, if you have an asthma patient, let them use HEPA filter. Let them use that. So I think that's a very strong message that if you can convince the clinicians to join this game using engineering approach, which in this case is a simple HEPA filter, that would be great. Now we wanted to sort of expand this thing to maybe less listening people like adults. And that, do they use it for long term? I think we have a trial funded by NIH to do this in Los Angeles. The biggest question is whether people will really want to use this, the compliance issue, whatever, for your intervention. We try to engage social scientists to understand behavior, that kind of thing. So what I was, mumbling says so much is I think those engineering approaches great. You test in the lab condition, whatever. We really need to deliver this to the public, to engage clinicians, to engage people who really are susceptible, older people with the disease, that kind of thing. We understand there's a huge individual differences in terms of response. For healthy people, maybe they less care. But for people who are really suffering from chronic lung disease, that kind of thing, may make a big difference in their life. Anyway, so I think what we're discussed here is great, all those technical details, but how to get that really into the people's life to make a difference. Maybe that's one thing we should think about. I think engineers can work with the health scientists. That will make a big difference. Thank you.
Thank you, Jim. And is there any response or anything to add? Please.
Hello. Okay. Hi. I'm Kristen. I'm from the University of Toronto. I kind of have a more general question, kind of with regards to like what Delphine said about getting rid of things from the source. Like, how do we as chemists and building scientists, how do we get consumers to realize that every single product that they are installing, that they buy, it's contributing to their own exposure? Like, how do we get people to look at every single item or purchase as a cost-benefit analysis to how might this product actually benefit my life relative to how it's going to cause me some negative exposure?
I mean, I'll say the key is to find some really excellent, there are researchers in media and in communications, and there are social scientists who truly understand how to do that messaging and how to interact with people. And there are success stories, and part of it is I think a lot like any other form of environmental regulation or policy is first having a strong grounding in the science. We'll never get 100% agreement, but we can make sure that the science is grounded, so what we're telling people is right. But then we have to start to engage other experts beyond the folks on this panel, and I think Jim pointed out to really talking to social scientists. I think that's the next step that really does need to be taken.
I think we need to be realistic, though. If we go back to Bill's 4 pillars of indoor air quality: control your sources, engineering controls, and now I'm blanking. Gosh, water control. Could reduce your sources. Then thank you. I don't do ventilation. I do air cleaning. We don't need ventilation. Turn it to 0. But control sources. And when you explain that, when I go out to interact, even with middle school kids, everybody's like, "Yeah, that makes sense. That makes sense." You just have to say those four things, and everyone's like, "Yeah, that makes sense." And you don't have to go deep into the chemistry and all that kind of stuff. But then I'm driving home in my car, and I'm listening to Pandora, and literally every single ad on my Pandora is for a certain laundry detergent. And that entire ad is about how it's going to make my clothes smell. Not how clean my clothes will be, but how it'll make my clothes smell. And so there's $1 billion industry on fragrances and bringing chemicals and our odor control, and it's subliminal into our lives of how good things are. And there's a psychological benefit that we have to think about when we're talking about these things. So we can't just say, if we just educate people, it'll be better. We have to be realistic that we have to acknowledge the psychological connection. We have to acknowledge the money behind the fragrances that are going into the industry, and we have to be aware of all that and not just blindly say, once people understand, that they'll change. And it's Bill's been doing this forever, and those 4 pillars, and we still are the same place dealing with radio ads about
Thank you.
Smells.
Yeah, it's more of a comment and a suggestion about air cleaners in general. And this comes from the experience of having worked with the EPA on air cleaner guidance for the home, and looked at the studies that we looked at for that, which was extensive for a couple of years. And also for the last effectively almost 4 years now, interacting with consumers and building owners and property managers on the subject of COVID-19 and what works and what doesn't. And it just became really clear really quickly, within a year, that what we can do is portable HEPAs. If they're operating. If they're not operating, they're not going to do any good. And one of the principal reasons that they're not operating is that they're too freaking loud. And the reason that they're loud is because the advice has been from everybody, put it on high. In other words, use it at the maximum volume. Now, we all know why that advice is there, so that we can get more air through the filter. But in fact, when people put it on high, they turn it off. And I will point to the example of schools. So schools, you buy one large one, you turn it on high, and then 2 weeks later, the teachers, one by one, turn it off, because you can't teach with that kind of noise in the classroom. So what we need is quieter. And what that means is bigger. And that what we need, therefore, is education about the fact that noise is key. And what we need there is a standard for noise or efficiency particle remover at some dB rating or zone rating. The number is 0.3 zones. At 0.3 zones, which is what you have from a Panasonic Whisper Green Select, exhaust fan for you really can't hear that very easily. Okay, that works. And when you get above that, when you get to the current ASHRAE standard for, let's say, exhaust fans, let's say kitchen exhaust of 10 zones, or excuse me, 3 zones, that is one order of magnitude louder than what it needs to be for a standard for exhaust fans. So we've got to get quieter stuff. And for that, we need standards. And for that, we need standards of effectiveness at a sound rating. That's what we need. It's an engineering problem. It's a standard setting thing. And that's none of us here are doing that. Okay, but that's where this will come. And then people will use the air cleaner that we know works, which is, HEPAs and portable HEPAs.
Thank you, Lou. And we could have a whole conversation on standards, but unfortunately, we only have a couple of minutes. So let's see if we can take both questions in this short time.
Okay, I'll keep it really quick and I'll pretend it's a question, but it's actually a comment. I think that we have focused too much on technologies and even on design of air cleaners and not enough on the context and how they're used. And that's what really makes a difference in performance. And so I guess if there's a question here, the question is, how do we address context when we're testing things in a laboratory and then they're used in a bunch of different buildings, changes over time, behavioral use changes? How do we address the context piece of the problem?
Thank you. And I'll choose to take that as a comment so we can hear one more question.
Okay, mine's relatively quick too. Just this week, the principal of my children's elementary school sent an email out to all the parents asking us, what should we do with this COVID-19 money that we have? And while I have the privilege of being around you incredibly intelligent people and can say to her with some education and resources, this is what you should do, why in the world is she asking me when she should be asking you, Katherine? What's going on? Why are we having this disconnect? And I'm just wondering if the EPA can lean in on some of this, because I've also heard from other schools, what COVID money?
Yes, unfortunately, we are at time. And I'll follow up with you in person. No, but I really want to thank all our panelists for the questions and everyone. Thank you very much.